Hey everybody, it's Unit 3, Video 9. We're working on applications of quadratic equations. I'm going to read two problems out of our textbook. If you'd rather read them with me instead of just listening, go ahead and grab your books now. And then after I do two problems with you, I've got here three extra problems I'd like you to try on your own just so you can demonstrate that you know how to do this without walking it through with me, and then bring those questions to class. Alright, so our first one is found on page 131 and it's number 8. I'm going to start by reading the whole problem with you and then I'm going to go back and break it down to pick out all the information that we need. It is a border problem. It is called the width of a flower border. A landscape architect has included a rectangular flower border measuring a flower bed measuring 9 feet by 5 feet in her plans for a new building. She wants to use two colors of flowers in the bed, one to fill the center and the other for a border of the same width on all four sides. She has enough plants to cover 24 square feet for the border. How wide can the border be? So going back to the beginning, she has a plan to make a rectangular flower bed measuring 9 feet by 5 feet. So we're going to draw that picture. 9 by 5, and she says she wants to use two colors, so she's going to map out another rectangle in the center, and the outside border here is going to be colored one color of flower, and then the center gets another color of flowers. But she wants to make the border the same width in all directions. So let's say she makes it X, because we don't know, that's the question, how wide can we make it? Well, if she makes the border X feet on both sides, then that makes the length of this centerpiece, the 9 feet that it started, minus 2x, because there's an x on both the left and the right. And the 5 feet in the vertical direction that it started, minus 2x, because of the top and the bottom. So if I were to look at the area of the outside, or the entire thing to be 45 feet, and I were to look at the center, now I only want to find the area of the border. I want to find the width of the border here. So if I'm finding the border, then I want to map out the center and remove it. So it's kind of like a picture frame problem maybe you've seen before, or an area problem in geometry where you're finding the shaded region. So that's what I'm looking for here. So this gives me 9 minus 2x and 5 minus 2x. Now what I do know is that if I were to take the outside, subtract the inside, I know that I'm going to have 24 square feet of flowers. And that's also given in the word problem. So we're going to go ahead and multiply the binomials by each other, leaving me with 45 minus 18x minus 10x plus 4x squared equals 24. I'm going to combine like terms with the negative 18 and the negative 10, and I'm going to distribute the negative sign. So minus 45, that will be plus 28x, and then minus 4x squared equals 24. Next thing I'm going to do is put this in standard form. That's going to involve moving everything to one side so that my equation is equal to 0, and writing everything in descending order. So I'm going to create a quadratic in standard form. So I will be left with negative 4x squared plus 28x minus 24. I have a GCF of negative 4, and I'm going to divide that out. So I have negative 4 times the quantity of x squared minus 7x plus 6 equals 0. If I divide both sides by negative 4, I'm left with only x squared minus 7x plus 6 equal to 0. And then I can factor that and use the zero product property. So I come up with two possible solutions. X can equal 1 or x can equal 6. Now maybe both work or maybe neither work. So I'm going to go back to my picture and check my answers. If I substitute in x equals 1, so the width of my border is 1 feet in all four directions, it would leave my center to be 9 minus 2 times 1, or 7, and then 5 minus 2 times 1, which is 3. So my center would be 21 feet, square feet. If I use 6 to check my work, I would have 9 minus 2 times 6. Oops, that's negative 3. And 5 minus 2 times 6, that's negative 7. While it does give me 21 feet, we're talking about this being the dimensions of a rectangle, so it doesn't work. My answer is only x equals 1. Let me read the question to you. How wide can the border be? My answer is the border is 1 foot wide. Let's try the next problem together. The next one is a completely worked out problem from the textbook on page 127. It is example 2. I'm going to read the problem to you, and then we're going to work it through. You can look at the book. You'll see the work is done there as well, but this way you'll get to hear it as in addition. It's a problem involving the Pythagorean theorem. Eric van Eggerding finds a piece of property in the shape of a right triangle. To get some idea of its dimensions, he measures the 3 sides, starting with the shortest side. He finds that the longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangle. I'm going to go ahead and draw this picture for you. Now, while I'm drawing, let's think of the possibilities of you finding a right triangle piece of property. Only in math class. But work with me. First, Eric measures the shortest side. We're going to call it x meters. I don't know how big it is, but he measures it. The book uses the letter S, okay? And then it says we're going to the longer leg, and that is 20 meters longer than twice the length. And finally, the hypotenuse is 10 meters longer than the long leg. So 10 meters longer would be 30 plus 2x. This is a Pythagorean theorem problem so that I can find the value of x. The Pythagorean theorem is a squared plus b squared equals c squared, where c represents the longest side of the triangle, the hypotenuse. So if I fill in my blanks, I will have x squared plus 20 plus 2x squared equals the quantity 30 plus 2x squared. I'm going to expand these quantities, giving me x squared plus, I'm going to rearrange it, we're going to get 4x squared plus 80x plus 400 equals 4x squared plus 120x plus 900. If you need to work out how I expanded those binomials, please do that on your own. And next I'm going to move everything over to one side so we can write this in standard form. I've got this equal to 0, and I will have x squared minus 40x minus 500 equals 0. And I'll factor and use the zero product property. X minus 50 and x plus 10 equals 0. X equals 50 or x equals negative 10. If this were not a word problem, those answers would be fabulous. However, we are talking about the length of, or a measurement, the length of this, the width of the lot. And I need to consider which would be an ideal answer. Negative 10 won't work. So 50 is the length of the shortest side. The question reads, find the lengths of the sides of the triangular lot. I can't just say I found x and I'm done. So if I go back, I will have a 50 meter length. We will have 20 plus 2x. So that will be 120 meters. And as the problem read, the hypotenuse is 10 meters longer than that, and that's what your answer will be. So these are the solutions. These are the 3 problems I'd like you to try in your notebook, and then you can bring those to class if you have any additional questions. Number 7 is another border problem. Number 21, another Pythagorean theorem problem, and give number 34 a try. I think you'll be just fine with it, so go ahead and give it a shot, and we'll talk about those in class.